Hi everyone, my name's Matt, and while this might look like an old VHS player on the outside, on the inside is actually a pretty powerful gaming PC capable of 1440p and even some 4K gaming. Also, this is more than just some parts slapped into a VHS player. I made sure to add some extra features like making the original power button turn it on and the power light illuminate. I even made the play/pause button work, along with having the fast forward and rewind buttons control volume up and down. Finally, I also found a way to start it remotely, making it more functional in a couch gaming setup. Now, this project was a fair bit of work and the end result is far from perfect, but I'm excited to share it with you and show the full build process. So let's get into the story of how I made this VHS player sleeper gaming PC. This project all started when a few months ago a family member of mine gifted me this broken Quasar VHS player, knowing I may want to build a PC inside of it. After looking over it, it actually seemed like it would be a pretty good fit for a project like this, so I decided to start with the early steps. The first thing to do was just some basic napkin math to see if I was even going to be able to fit a full gaming PC worth of parts into this makeshift case. So I just took some parts that I had on hand and laid them out to see what kind of layout I'd be able to do. I was definitely going to be able to fit an ITX board and a good sized graphics card, but an SFX power supply wasn't going to fit, so I was probably going to need to use something like a Flex ATX unit. Now, if I didn't have these parts already, I could have alternatively made some paper templates with the basic dimensions of the parts I was going to use and lay them out that way. Even better, I could have laid out the parts or templates first, then measured them and found a VHS player that would fit my desired parts and layout. With that being said, I was pretty sure I'd be able to cram a full gaming PC into here, so I decided to proceed with the build. This meant it was time to open up the VHS player and remove all the internals. I started by removing all the visible screws that I could find and then pulled off the top panel. This revealed a slightly dusty interior and an old copy of The Lion King, and when trying to remove the VHS tape, I also found this random hourglass. I pulled off the front panel, removed the power supply, and just continued to tear it down, taking a quick break to play with the gears and mechanisms. Then a few minutes later, I was pulling the final internal piece out of the shell. With that, I was left with the plastic base frame and the metal cover, which could act as the canvas for this build. Now, because of the various plastic standoffs and pieces inside of the base, I wouldn't be able to fit in parts as is, so it meant it was time to start removing standoffs like this and bracing pieces like this. I'm going to start by using my rotary tool with a cutoff wheel. You can get a rotary tool like this for around 20 bucks, and if you're trying to just cut through stuff like plastic and aluminum, it'll work fine. I use this to get the big standoffs removed like this one and a few other big ones. I guess this is also a good time to mention that a goal of this project was to try and use more basic tools that most people have access to or that could be acquired for pretty cheap. So no 3D printers, laser cutters, CNC machines, or expensive saws. With the big standoffs removed, I could use some basic flush cutters to remove a bunch of little pieces with the goal of getting as flat and even of a surface as possible. I was actually able to remove a lot with the flush cutters, and after about 4 or 5 minutes, I was left with this. Not perfectly flat, but good enough for now. I brought over some parts and was happy to see everything physically fit inside and the top cover able to slide back on. After playing around with placement for a bit, I realized that if I'm able to have the GPU I/O and motherboard I/O protrude out the back of the case, even just a few millimeters, it'll give me enough room to do some of the mods I want at the front of the case. This meant the best course of action now was to cut out the back panel as it would get in the way otherwise. I started out with the cutoff disc, then went in with the flush cutter, then back to the cutoff wheel to do this long span at the bottom, and then returned back to using the flush cutters to get things flattened out more. When that was done, I was left with the base frame minus the back panel. At this point, I was ready to start measuring for the internal frame, which I decided to make out of angle and bar aluminum. I was going to get an 8-foot span, but they were out of stock, so I just grabbed two 4-foot pieces of 3/4 inch by 1/2 inch angle aluminum and a 3-foot span of 3/4 inch bar aluminum. The plan was to cut pieces out of the angle ones, then bend them to make the main parts of the frame. You can do this by finding the point of where you want to make the bend, then marking out 2 lines 45 degrees from that point. Then, if you cut out the section you just marked with something like a hacksaw or cutoff wheel, file down the edges a bit for safety, and bend the aluminum, you're able to create a right angle in it. Using a tape measure, I could make an internal measurement of the case and transfer it to the metal, marking where I should make the second bend and marking the 45-degree angles. Then, just like the last bend, I simply cut out both of the lines I just drew and bent the metal into another 90-degree corner. Bring this over to the base piece, you can see how this part of the frame will fit in. Next, I could measure the internal width of the frame and transfer that measurement to another piece and then cut it out. After filing it down a bit, it fit into the back of the frame how I wanted, and I was then able to bring over an ITX board and GPU to see the forward and back placement of this new piece. When I had it where I wanted it, I marked the intersection on the U-frame. Next, I drilled a hole into each end of the new piece of aluminum and placed it back into the U-frame using the new hole as a guide to mark and then drill a hole in one side of the frame. Then I could test fit the piece using an M3 nut and bolt, make sure it was square, then drill and attach the other end. Then I went ahead and cut the excess off of the long end and the short end of the U-frame, and with that, I had the basic frame I was going to use to build off of and mount all my hardware to. The motherboard was going to need another span across the frame to mount it, so I placed the motherboard in the approximate location I was going to mount it and marked the front to back location of the two motherboard holes. Next, I took another internal measurement, transferred it to a piece of bar aluminum, and cut it out with my hacksaw. After getting it exactly the width I wanted, I could set it in place, drill and attach the first side, then making sure the span was square, doing the same thing for the other side. Putting the frame back in the case, I brought over my ITX board and GPU to start looking at placement. I decided I'd mount the GPU to the motherboard using one of these right angle riser cards to keep things as flat and low profile as possible. Once everything was lined up how I wanted it, I marked then drilled the first hole, put the board onto the first bolt, and then marked the back two mounting points and drilled them out as well. The way I decided to mount this board is in each hole first attach a 15 or 20mm bolt, tighten it down with a nut, then partially screw down another bolt that'll be used as a height stop to keep the board in a specific place vertically. Then the board can be placed on and another bolt used to secure it down. Now, because one of the motherboard holes is offset, it meant I only had 3 mounting points right now, but I'll address that later. For the power supply, I realized that even just raising it up a few millimeters meant it would interfere with the top closing, so I need to have it sit directly on the bottom plastic, but also need a way to secure it in place. I found out that placing a piece of angled aluminum right up against the bar for the motherboard created a pretty precise opening and guide for the power supply to fit into. So I cut and then grinded down another angle piece that I lined up, drilled holes in, and attached to the main frame. This was a good step forward in getting the power supply aligned and mounted, but I realized this new piece was occupying space I needed for the graphics card. To fix this, I started by cutting halfway into this new piece, then using a cutoff wheel, I could cut this big span in the aluminum, and then filed down the newly cut edges. With that, the piece was reattached and able to give some spatial guidance to the power supply while also allowing the graphics card to be plugged in and unobstructed. Next, I needed a way of securing and supporting the graphics card, so I brought over and marked another piece of angle aluminum that I then cut with the hacksaw. I drilled 2 holes into this bracket piece along with one in the frame, attached it, and as you can see, I somehow was way off on the other hole, so I drilled a new hole through both pieces and attached another nut and bolt. Then I could bring the motherboard and GPU back over to the frame and carefully mark where the GPU I/O bracket would attach on the frame piece that I just made. A few holes later, along with a nut and bolt, and I was happy to see the GPU sitting supported how I wanted it to. I now needed a way of attaching the power supply to the frame. I decided to tap into these holes on the power supplies, so I cut another piece of angle aluminum and lost the footage of it, but I notched out part of it so it would slide into the frame like this. Then it was just a matter of marking and drilling holes that would allow the bracket to attach to the frame and the bracket to hold onto the power supply. This isn't a perfect solution, but for a PC that's not ever really going to be moved around, then this will work perfectly fine. I also created this other small piece that mounts to the frame and allows the motherboard to be securely attached in all 4 corners. With that done, I had the basic mounts completed for all the PC hardware itself, but this project was far from over. Before I could move on to the front panel stuff, I needed to finish up a few more things. The first was countersink all the holes in the frame to allow the screws to sit flush like this, and then second was to address venting. For the GPU, I marked the openings in the frame onto the plastic below, then I went ahead and cut those pieces and also added 4 small rubber feet to the shell, which in combination with the new GPU vents should provide decent airflow. Now, the CPU was not quite as easy. During initial testing, I found the GPU was staying reasonably cool while gaming, but even after just 5 or 10 minutes, the CPU was getting above 90 degrees. Now originally I planned to make a venting grid along the top panel by adding blue tape, marking a bunch of lines, then marking where I should drill each hole, but after marking 30 or so spots, I realized this probably wouldn't turn out how I wanted it and decided to scrap that idea and focus on just adding venting directly above the CPU. So I had ChatGPT create a printable grid about the size of the CPU fan, which I lined up and taped down, and then proceeded to mark all the center points of each hole. This left me with a bunch of precise spots to drill into, so I started by drilling holes in each spot with a smaller drill bit for alignment. Then once all those were drilled, I took the final size, which was 1/4 inch, and drilled each hole larger. Then I went back with a deburring tool to try and clean up each hole. This venting didn't turn out amazingly, but with a little more deburring and maybe a fresh coat of paint, it could look more stock. With that being said, it's not really noticeable unless you get up close. It improved temps significantly for the CPU, with the CPU only getting into the upper 70s after about 10 minutes of testing. With the hardware physically fitting and not thermal throttling, I decided to move on to the next steps of the project. The next phase was to add some functionality to the front panel of the case. This includes making the power button functional, the power light illuminate, and adding media controls. The way these original buttons work is pressing them in horizontally actually makes these plastic pieces hinge downward. I realized that pieces of angle aluminum oriented like this fit just outside the frame's designated space, meaning I could mount buttons to pieces like this and add my desired functionality. I cut out 3 different pieces of angle aluminum to act as mounts for 4 buttons. I put them in place, marked them, and drilled holes into the brackets and corresponding holes into the plastic shell. I was worried about being able to get the nuts into place, so I decided to try and super glue them onto the brackets, which worked for the most part. For the buttons themselves, I have this variety pack I got from Amazon, and after looking at my options, I found that if I bent the contact points up on these long ones and set them onto pieces of angle aluminum, it put them at the perfect height to be actuated by the buttons. To get these switches ready, I started by cutting and stripping the ends of a few short jumper cables, then soldered 2 of these cables to each of the switches and used some heat shrink on the connections. I also took a red LED and attached 2 more of those jumper cables in the same way. This way I can take a male to female jumper cable of any length I want, plug one end into the switch or LED and then the other into a header. These buttons were glued to the bracket using super glue in the approximate locations that I marked. The power button and LED are going to plug directly into the motherboard, but the other 3 I want to use as media controls. I knew I could probably use an Arduino to do this, so I again headed over to ChatGPT and asked how I might be able to go about this. The Arduino it recommended me to use was a Pro Micro, which I was able to get a 3-pack of these knockoff ones for like 12 bucks. I went ahead and soldered the included header pins to the Arduino so that I had a place to plug my jumper cables into. I also soldered up this 3-to-1 jumper cable that I could use to hook up all 3 buttons to a single ground pin. So I took the Arduino, plugged in the buttons how ChatGPT told me to, and uploaded the provided code to the Arduino. After a minute or 2 of troubleshooting, I had functional media buttons with one controlling play and pause, the second being volume up, and the third being volume down. Now this does require a USB connection to the computer, but I don't want a cable being routed out of the case into the back I/O. To alleviate this, I can use one of these USB 2 internal connector adapters to keep all the wiring inside of the case, but I also needed to split this USB 2 connection for the next feature I want to implement. The feature in question is the Silverstone ES020-USB, which plugs into a USB 2 header and allows you to remotely start your PC with this car key looking remote. I just found out these existed and wanted to try one out, as a system like this would probably be used in a living room where you're going to want to turn it on remotely from the couch. In the box you get the control board itself, along with a remote, a little screwdriver, and conveniently a USB 2 header splitter that I'll need to hook up both this guy and the Arduino to a single USB header on my board. With that being said, I also have a different USB 2 header splitter as a backup just in case. So with that part explained and ready to go, I think it's time to assemble it all together. But before we do the final assembly, let's talk about the parts I decided to throw in here. For the CPU, I debated a bit on what to go with, but because the system is more meant for high fidelity AAA gaming, I really didn't need anything very powerful, so I decided to go with the AMD Ryzen 5 5600. This is a 6-core 12-thread CPU on the dead AM4 platform. With that being said, it's still great for budget gaming and offers a good value at a little over $100. Now, for about $100 more, you can get yourself into the AM5 platform, which is what I would recommend for the vast majority of people, but I specifically picked this CPU because I wanted to see how it would pair with the GPU I went with, which we'll talk about in a minute. To cool the CPU, I went with a low-profile Thermalright cooler that I had on hand, which offers a good amount of cooling performance in a pretty compact package. The CPU is going into the Gigabyte A520i AC. This is a $99 AM4 ITX board with all the features I needed and not much more. It's got decent back panel I/O with built-in Wi-Fi, fits all my hardware, and was relatively affordable. The only real downside I see of this board is the fact it only has a single M.2 slot, meaning upgrading storage in the future would require a SATA drive or replacing your existing M.2 drive. Moving on to memory, I went with a 2x16GB kit of Corsair LPX DDR4 at 3600MHz CL18, which comes in at around $78. I use this kit because I had it on hand, but I'll link a comparable and cheaper kit in the description along with all the other parts and materials mentioned in this video. 32GB is the sweet spot right now for gaming and is all you really need unless you're using your PC for more than just basic tasks and gaming. For storage, I went with something that I had on hand in the form of this 1TB Crucial P1. This is a Gen 3 NVMe SSD in the M.2 form factor that you can't buy anymore, but you can get the newer 1TB P3 Plus for a little over $60, which I recommend and I'll link below. I think 1TB is the minimum I would go with, especially for a system like this with only one M.2 slot. 1TB will give you enough room for your OS, applications, and a small library of your most played games. For the GPU, I went with what is the obvious mid-range option right now, which is the AMD RX 9060 XT 16GB, which comes in at a little under $400. I was actually blown away by how good this card performed when I tested it with an AM5 based system, and was very curious to see if the 5600 would keep up with it when gaming at higher resolutions in a not so CPU bound scenario like 4K couch gaming. The 9060 XT 16GB is a great 1440p card and can even play a number of games in native 4K. The particular model I have here is the dual fan Sapphire Pulse version. It's a relatively basic GPU, but it comes in at around $380 right now and performs as expected for a 9060 XT. To power this system, I would have loved to use an SFX unit, but as you've seen in the case mod section, I ended up needing to use a Flex ATX power supply. I went with this 400 watt 80 plus gold rated unit from FSP that comes in at around $100 right now. It's loud, it's got ketchup and mustard cables, and it's not got a ton of power, but it gets the job done and fits in the case. If you're doing a project like this, HDPlex offers some pretty amazing small form factor power supply options that are fanless, meaning they're silent, but they also do cost a fair bit more. Also, I'll be using this extension cable to get power to the power supply from the wall. And for the case, well, you should know what I'm using by now. Cost-wise, this set of parts minus a case is about $850, but again, for about $100 more, you could go AM5 with a 7500F, which is what I would recommend most people do. So now that you understand what's going into this VHS player PC, let's put it all together. First, I installed the motherboard onto the blank frame and then plugged in the USB splitter and the wireless front panel receiver, which plugs into the splitter. Then I could set the power supply into place and screw it in most of the way. Then to prep the shell, I installed the 3 button brackets and also just electrical taped the power LED to the correct light pole here. Then the frame could slide into place and the power supply be tightened down the rest of the way. Next, the GPU with the riser attached was plugged in and the GPU itself was secured to the bracket at the back. Then it was just a matter of plugging everything in, which was simple for the main power cables along with the power button and LED, but the Arduino for media controls was a little more complex, but I did get everything plugged in the end and finally was able to slip on the top panel. Pressing the power button, I was happy to see the system spin up and the power light illuminate. I was also happy to see in Windows the media buttons working exactly as intended, and the remote was able to shut the system off and turn it back on. So everything seemed to be working how I wanted it to first try, which was awesome. And with that, the physical build was complete. But how does it perform? Well, I decided to test the system in Windows, but I would recommend installing a Linux-based gaming distro like Bazzite onto a system like this, which I checked out about a month ago and found it amazing to use. With that being said, testing performance is easier, at least for me in Windows. I didn't test a ton of games, but I tested them all at 4K, aiming for 60 plus FPS, which did require some upscaling in the majority of titles. Starting off with Cyberpunk at 4K using the medium preset, I saw the built-in benchmark provide a solid 100 FPS average with 1% lows of 69, which is very solid performance in my opinion. In Borderlands 3 at the 4K medium preset, the built-in benchmark provided an 84 FPS average with 1% lows of 69, and this is a good example of the type of game that can run on this system at native 4K with 60 plus FPS. In Black Ops 6 at 4K using the Ultra preset and the built-in benchmark, the system put out a solid 82 FPS average with 1% lows of 60, which seems pretty good in my opinion, and I know AMD does particularly well in this game. Black Myth Wukong at 4K high requires 50% resolution scale to produce a 60 FPS average with 1% lows of 49 in the built-in benchmark, which again is decent performance. In The Last of Us Part 2, I tested at 4K with the high preset and FSR 3 set to quality. Doing this resulted in a 72 FPS average with 1% lows of 58 while playing a random section of the game. Finally, in Monster Hunter Wilds at 4K with the medium preset, the system put out a 61 FPS average with 1% lows of 43. I note this a lot, but 60 FPS average in Monster Hunter benchmark tool can be a little deceiving, as many of the sequences have the FPS staying in the 40s. All in all, for 60 FPS 4K couch gaming, this sub $1,000 set of parts does pretty darn well. Yes, most games require upscaling, but they still look and play great in my opinion. Noise-wise, the system can get pretty loud thanks to the Flex ATX power supply. Temps are acceptable for both the CPU and GPU, meaning my venting methods were a success. All in all, I'm pretty happy with how this project turned out, especially while using a relatively small set of low-tech tools. The back is wide open, but you're not really going to ever see that, and closing it off would probably do more harm than good temperature-wise. With that being said, I'm interested to hear what you guys think of this project. What would you have done differently if you were doing it yourself? Let me know in the comments below. So yeah guys, it's time to wrap this video up. Give this video a like if you liked it and consider subscribing. And as always, this is Matt from Tech by Matt, signing out.